All right, this is a worksheet that we did along with lesson 3.4, finding the equation of a line given 2 points. And here, we're just going to focus on slope for this problem. And so we're going to start by finding slope with a graph. And what you want to do is find 2 points on the graph that hit grid marks. Now, what I mean when I say grid marks is, do you see where the vertical and horizontal lines meet? These little, where I'm putting these points, these are grid marks. So what I want to do is find out, where does this line hit these grid marks? So if I start here and I go here, it hits one line, it hits the horizontal. But it doesn't hit a vertical and horizontal at the same time, so that's definitely not the value. All right, so for this here, we're going to go ahead and go down to the next point. Oh, this does hit a vertical and a horizontal, so I'm going to put a dot there. As I can continue down, it hits just a horizontal, just a horizontal, just a horizontal. When I get here, it does hit another grid point or grid mark. And then if I continue down, just a horizontal, just a horizontal, just a horizontal, and boom, here's another one. So I actually have 3 good points on here. Once you find 2 points, you're going to go ahead and make a slope triangle. And I always recommend going down and over. So draw down, draw over. And here we have 1, 2, 3, 4 as the length, and this length is 1. So our change in y over a change in x is 4 over 1. Or just 4, right? I like that better. Why do I do 4 over 1 when you can make it simpler? Right. For your next one, you're going to do the same thing. And so actually for these next 3 graphs, I want you to go ahead and find the grid points on there, and go ahead and find, make your slope triangles and find the slope. I do want to caution you. This first line goes uphill, which gives you a positive slope. Not all of them go uphill, so you have to think about, what does it mean when your line goes downhill, right? And how does that affect your slope triangle? All right, so go ahead and pause and work those. All right, I'm hoping you have these 3 problems done. I'm going to go ahead and work number 2. So here, I do have a nice point right here on the edge. If I follow down, here's the next one, and the next one. Apologize for my cat. My cat's meowing. All right. And you just pick any 2. I'm going to pick these 2 here. I think they're pretty easy to use. I'm going to draw that line down. I'm going to draw that line over. All right, and so here we have our slope triangle. This distance is 2, this distance is 3. So our change in y over our change in x is 2 over 3. I just want to remind you, when you do your slope triangles, I recommend always putting them under the line. When they're under the line, this number here on the side is always the top number, and this number that's down here is always the bottom number. So they kind of occur in the same locations they occur in your answer. But if you put your slope triangle above it, it'll be flipped. So I think under is better. All right, let's go and go to the next problem, number 3. So this one, we have pretty much almost every point here is a good point, right? I'm going to do a nice big slope triangle. And I want to point out, if you do a bigger slope triangle, all that means is you're still going to get the right slope, but you can reduce the fraction. So here, this will be a 3 over 3. Right, this is 3 down and 3 over. This 3 is negative because this goes down. This goes down. And so it goes 3 down and 3 over. So your change in y over your change in x equals negative 3 over 3. And then it reduces down to just negative 1. Now, if you did a smaller triangle, like this really small one, this would be negative 1 over 1, which is still negative 1. It's the same slope. But if you use a bigger triangle, you will have something that you have to reduce. All right, now let's go to this next one here. And for this last one, looks like there's a good point here. And the next one is here. So I only see 2 really good points. So I'm going to draw this line down and over. And this does go down and to the right. I want to point out, when you do these other ones, and I know we drew down and over, but really we go left to right when we look at it. So this one is really to the right, which is positive, and up, which is positive. So these are both positive directions. But when we start here, at this point, it goes down and to the right. So this value is actually negative. So 1, 2, 3, 4, 5. That is a minus 5. And this is 1, 2, 3. So that is a 3. So your rate of change is going to be negative 5 over 3. So negative 5 over 3. All right, so that is your slope for this last one. Now, for this last set, you don't have graphs. In fact, I tried to put values that wouldn't fit on small graphs like the ones above. And so this one, we're going to have to use a different method to solve it. And that there's two different ways, but I'm going to really focus on the y sub 2 minus y sub 1 over the x sub 2 minus x sub 1. You could do a table version. So if I did this and I have negative 4 and 12 and negative 3 and negative 7, I tend to find the table method isn't as intuitive, and that I start seeing sign number errors on this. Like if I go from 12 to negative 7, am I increasing or decreasing? Well, I am decreasing, right? It's definitely going down. How much did I decrease? You're going to decrease by 19. And so a lot of times I'll have people want to say 5, but if I decrease by 5, that just puts me at a positive 7, not a negative. And then here, if I go from negative 14 to negative 3, that's actually an increase. And so sometimes this can be a little confusing. And so this equation typically I see most students refer to, but if you're fine using this method, that's fine. But I'm going to go ahead and do this one. So my y sub 2 is this value. My y sub 1 is that value. This is my x sub 2 and my x sub 1. So these are the values for the second point. That's why these have 2's. These are the values for the first point. That's why they have 1's. And so if I follow this by plugging in these values, y sub 2 is negative 7. Then there is a minus sign in the equation. So I'm going to put the minus sign in here, and y sub 1 is 12. So I'm fine. I don't feel like I need a parenthesis here. The 12 value that here was not negative, but remember we talked about if you're plugging in a negative number, put a parenthesis around it. Let's deal with the second one. X sub 2 is negative 3. There's a minus sign in the equation, so we put a minus sign. X sub 1 is negative 14. We put a parenthesis. That's super important. So these values are now correctly plugged in. The first thing I would do is resolve any double negatives. Here, this 14 has 2 negatives assigned to it, right? Both of these are assigned to that 14. So I'm going to rewrite the problem to negative 3 plus 14. Remember, double negatives become positives. Now you can actually start solving the problem. At the top, is that a war or an alliance? Negative 7, negative 12, that is an alliance of negatives. So you get negative 19. And on the bottom, this is a war, negatives versus positives. Positives win. There are more positives than negatives. And you fight the war. In a war, you always subtract. So how many positives will be left over? 11. So your answer is negative 19 over 11. I do prefer to bring the negative out front. It's okay to leave it in the top. It's not necessarily wrong to put it in the bottom, but you'll almost never see that in a textbook. We almost always put it either out front or up top. All right, so there are 3 more problems here. I'd like you to go ahead and work those 3 problems. So pause your video, and then we'll go over them when you're done. So hopefully you have the remaining problems worked out. I'm going to go ahead and start on this one. So for this one, my y sub 2 is 7. So I'm going to do 7 minus, and then I look at my y sub 1, negative 5. So hopefully you remembered that there are 2 minuses here, one from the equation and one from the value of y sub 1. Draw my line, and then x sub 1 is 9 minus my x sub 1 is negative, so we put it in its own parentheses. So in this case, both the top and bottom, they both have double negatives. So when you resolve this, this actually becomes 7 plus 5 and 9 plus 13. And if I add the tops, I get 12. And if I add the bottoms, I get 22. So 12 over 22 is our answer, but it's not our final answer. This is not fully reduced. So just a reminder, you can plug these into your calculator as a fraction, hit enter, it will reduce for you. But what I'm noticing on these two, they're both even. And so they're both divisible by 2. 12 divided by 2 is 6, And 22 divided by 2 is 11. And 6/11 does not reduce. 11 is a prime number, so that is going to be your final answer for number 6. Let's go to number 7. Boy, lots of negatives here, right? So we want to be real careful. Y sub 2 is negative 4 minus y sub 1, which is 17. So I don't necessarily need a parenthesis around that. X sub 2 is negative 15 minus x sub 1, which is negative 8. That is a double negative, so we are going to have to resolve that. So negative 4 minus 17 over 15, negative 15 plus 8. All right, just double checking I have all my negatives there, and this negative turned to a positive. Now let's start combining. Negative 4 and negative 17, if we combine those, is that an alliance or a war? That is an alliance of negatives, so they're going to team up and make a bigger group of negatives. So that's a negative 21. Now the negative 15 and the positive 8, that is also, or that is a war, negatives versus positive. Negatives will win. There are more negatives than positive. When they fight, what's left over? There'll be 7 negatives left over. And now we can simplify this fraction. And I notice that 7 does divide evenly into 21. So we don't have to have a fraction as our final answer since it goes evenly. 21 divided by 7 is 3. Now, is it positive 3 or negative 3? Well, we have a negative divided by a negative. And what's the rule for that? When we're dividing, negatives cancel in pairs. So these negatives cancel, and you wind up with a positive 3 as your answer. All right, and then for the last one. So we're going to have 14 as our y sub 2 minus the y sub 1, which is negative 2, so it goes in its own parenthesis. Draw your line. We have a 12 as your x value minus negative 14 as your x sub 1 value. And so once again, we have a situation where we have double negatives in both the top and bottom. So this is actually 14 plus 2 and 12 plus 14. So that is 16 over 26. So when we add those up, and then we need to simplify that. This is divisible by 2, both the top and bottom. 16 divided by 2 is 8. 26 divided by 2 is 13. 13 is prime, meaning it won't divide by anything but itself in 1. So that fraction is not going to reduce down anymore. Once again, when you get these fractional answers, you can always plug them into your calculator and verify. All right, that finishes this worksheet.